Hey, everybody. Thanks again for taking some time out of your day again to come watch another session of DynamoDB Office Hours. My name is Rick Houlihan. I'm a principal technologist for NoSQL at DynamoDB, or at AWS. I work on the DynamoDB service team. As many of you know, I do a lot of data modeling videos and whatnot. Today, I have a really special guest. John Lee. He's a member of the Dropbox technical team. He's actually technical lead on a really critical, mission-critical service that was recently launched at Dropbox to manage their metadata storage. And we're going to talk today about how that team went through the process of building that internal service. So let's just bring John online. Thanks a lot, John, for joining us today, and welcome.
Thank you, Rick. Yeah, good morning.
Yeah, nice to have you on the show. Now, I'm sure most of our viewers already know about Dropbox, what Dropbox is. You guys are a well-known company, but maybe some might not. We have a lot of global international customers who might not be familiar with the service, even though you are global. So can you tell us a little bit about Dropbox and specifically, your role on the team? And I know that people are really interested in, the metadata storage service that you helped build. So if you could give us a little bit of the history of that service, that'd be great.
Yeah, so I think most people know about Dropbox's core product, File Sync and Share. But Dropbox, we're sort of a global collaboration platform. We have over 600 million users in about 180 different countries. We build products basically to help teams work more efficiently and sort of focus on the work that matters.
Nice.
So we've got the File Sync and Share, we've got paper, transfer, file requests, and a lot of other various products in the pipeline. Myself, I am the technical lead on the storage platform team.
Okay.
And our team sort of provides easy to use, reliable, secure, compliant, cost-efficient storage for user file data, block data, and also cold metadata by sort of using whatever appropriate storage backend, such as S3 or MP, which is our own storage service, and then building whatever our own storage services that we need.
Nice. Great. So, today we're here to talk about metadata storage, right? So a lot of people, like you said, your core service is storage, the objects people store, but, the metadata that surrounds that, is actually, is significant because that's really what people need for like auditability, traceability, right? Who did what when. I mean, this is the things. It's one thing if I'm just an individual user and I'm storing my own objects but for your corporate users especially, right? There's a lot of audit log requirements and financial requirements around auditability of data. So that's more or less the service we're here to talk about today, right? Is the end of your business that manages all of that traceability and almost like log events, right, for the storage service.
Yeah, so I think at Dropbox is a little bit unique because we have a very clear separation between sort of block data and metadata. Mm-hmm. So metadata at Dropbox means all the small stuff that sort of powers our products. Audit logs is one of them. Anything that might go into a database at another company is what we refer to by metadata.
Okay.
So we own a metadata service called Alki that stores cold metadata specifically. And this means like metadata that sort of is written very often, but it's very rarely accessed. So you can imagine for audit logging, anytime you interact with Dropbox, you might be writing, an event row that says, okay, somebody has shared this file or somebody has viewed this file. But very rarely are admins actually going to go and look at those logs. It's very verbose.
Right. It's write heavy, read light. Right. Yes, These are typical logging workflows. Right. But you know what? When you need the data, you got to have the data. Yes, right. Exactly. That's what it comes down to. Right. And I imagine there's like a life cycle to this data. Right. It's not always hot all the time. The data that is read, like you said, is not read often. But when you need it quick. But then at some point, it's like, okay, this data is not so important to me anymore. Right. And so you kind of got to map all of that into the data architecture of the service you're building, right? It can't just be one size fits all, so to speak.
Yeah, so we've basically designed a system that sort of ingests data into DynamoDB as sort of a hot tier. Okay. And then over time, we have a whole system around offloading this data into S3, but maintaining sort of an indexable mapping of all this data so that from Alki's like API perspective, you don't care where the data is in DynamoDB or in S3, we still serve it. if you
Right.
if you need it. Yeah.
It's just, yeah, at some rate from this store. So this is nice. I mean, this is a great kind of end state, but how'd you get there, right? I mean, let's talk a little bit about the journey, right? I mean, you don't start off with this wonderful, perfect solution, right? There had to be some pain in the organization, some way that you guys grew into this. And I really want to focus on some of this stuff, because a lot of the times when I talk to people about, why cloud, right? Why do you want to use cloud native services? And I read through, there's a great blog post out there, folks, that for those who are interested. I'll go ahead and post the address into the chat here. We're going to talk a lot to the journey that Dropbox took to get to where they are, and these talk to a lot of the value points of cloud native services, right? Things like operational pain, the inflexibility of the technology solutions that you're building. Let's talk a little bit about what that journey looked like for Dropbox. How did you guys get to where you were? When did you make the decision that you got to go here? And what were some of the driving factors in making that migration?
Yeah, so we go over this in a bit of detail in that blog post that you just mentioned. But the gist of it is that we also have this other metadata storage service within Dropbox. And this thing is sort of a one-size-fits-all metadata storage service that we've built about over a decade ago. So before there were really any popular open source industry standard things that people were using.
Yeah.
So we had sort of built this NoSQL thing on top of sharded MySQL.
Okay. Yeah.
And,
I mean, it was a common approach, right? I mean, this is something people did, right? We had, it's almost like you roll your own NoSQL database, right? I mean, it seems like, yeah.
Yeah, so this thing's called EdgeStore. We designed it basically off of Facebook's Tau, which is sort of a very similar sharded MySQL type metadata store. And for a very long time, this thing worked very well. We were able to store and power all of our products using EdgeStore. But one of sort of the downsides at limit, at scale, is that capacity expansion in EdgeStore only worked by sort of doubling the number of shards that you have.
Sure.
So we didn't have any sort of dynamic partitioning scheme in this. So the only way you could do it is to just split the shard space entirely. And you would sort of take, we have multiple databases running on a single MySQL host. You would just take some of those databases and put it on a different MySQL host.
Right. So like we got on the screen here, that's that kind of screenshot, right? It sounds like what you did was you kind of decided when you built the EdgeStore is going to have X number of shards. We're going to distribute the data relatively evenly across this number of shards. And then as we need to expand the system, that's great, because we'll have these kind of pre-sharded buckets that we can just migrate from, instead of this guy running 4 shards, we'll have 2 hosts running 2 shards each, right?
Exactly.
And so, I mean, as you kind of go through the story here, you hit the point where it was like, well, that's great, but we're only able, splits became expensive, right? Because, I mean, you started with a huge number of shards, a small number of hosts, but as you split and split and split, right, it becomes extremely expensive to start to manage that. But, what were some of the timelines you guys were looking at in the end when it came down to, okay, we've only got so many splits left, and this is the cost per split, and what was the deadlines that you guys were running into, and the basically where you were like, at some point we can't go any further with this.
Yeah. So when I joined Dropbox back in 2016, we had just split from 16 shards per cluster to 8 shards per cluster.
Okay.
And then within about a year and a half, we were at 4 shards per cluster. So we had split another time. And we were predicting that sort of at the growth rate that we were expecting, we would need to split again in about a year, and then again half a year later.
Oh boy!
So
it's like crunching, right? You're getting, and this has to be driven by growth in the business and demand for the metadata service, right? It's like multiple factors running in on you.
Yeah, so it was sort of a good thing that we would need to split, because that sort of means that we've got a lot of data to deal with.
Right.
But at the same time, it was definitely very scary to stare down at the sort of the barrel of the gun, knowing that we had just under 2 years to sort of resolve this. Otherwise, we'd be down to 1 shard per cluster, and we don't really have any easy means to
I mean, what do you do at that point, right? You have to redistribute the data across more shards, right? There's only it's reshard, right? And you're just like in a major issue there when you talk about capacity. From numbers perspective, you can see some of the numbers on the blog post here, right? It's from like you said, from 8 shards per cluster to 512 clusters with 4 shards per cluster. And then when you look at 512, shards, or for 4 shards per cluster, that's a cluster is 3 servers, right? You're talking over 1,500 hosts splitting to another 3,000 hosts, and I think you mentioned it's an all hands on deck exercise at that point, right? When it's like everyone in the company knows how to install a box, get into the data center now, right? I mean, it's like, and even if these are EC2 instances in a cloud provider, you're still talking about enormous effort to get this thing to deploy at scale, and every scale choice is almost like, since the shards are not really growing independently of each other, it's always a split across all hosts, right? There's no, this shard needs to split, that shard needs to split. It's always, if this one needs to split, the rest of them are right behind it. So because
the data is fairly uniformly spread. That means that once one shard is about to split, the median set of shards is also about to split.
They're all there, so might as well do it, because it's not going to save you anything to try and identify the ones that are hot, right? I mean, this is one of the things I talk to all the time. I mean, this is not a unique problem you guys ran into. I mean, I've had other customers as well who run into these issues, especially with these types of self-managed, partitioned, SQL at scale, right? It's when it gets tough to manage this, and the resources you invest in it are tremendous. So I imagine that was something where the team started looking at that and saying, look, this is where you start looking at we're at a break point. How do we what do we identify as potential solutions? And so let's talk a little bit about that. What were some of the things that the team looked at when they got into, okay, this is broken, going to need to fix this. We have, X amount of time in our runway. And really what it comes down to is like 1.5 to 2 years, it sounds like, until we're at the break point. So, as an organization, this is a challenge that is mission critical, right? So what were some of the processes that your team went through to identify a solution?
Yeah, so I think initially we sort of tried to Band-Aid fix this a little bit. So we implemented retention policies. We tried to get customers onto those. But obviously, like, if you're a product, you don't necessarily want to think about how long you want to keep your data around. Ideally, you can keep it around forever.
Sure. Well, everybody would like that, right? In the magical, mystical world, right?
So obviously, we weren't able to get a lot of product metadata onto retention policies. We started looking at like bitwise optimizations that we could try to do with the data that we were storing in MySQL.
Sure.
We played around with different MySQL optimizations, using different storage engines, different compression schemes, different on-disk file systems.
Right.
Maybe do hole punching, stuff like that. But I think the complexity of all of that was
non-trivial.
Was non-trivial. Yeah, and it sort of posed a lot of risk to try to do this onto like an existing live running database that's powering all of Dropbox. Right. So at some point, I think we sort of stopped, and we started to really take a look at the data that was within EdgeStore itself. And so we kind of realized that, like, at scale, this sort of one size fits all doesn't quite work.
Right.
There's a lot of different types of patterns of data.
Sure.
And specifically, we sort of identified this sort of log data that was actually being stored in EdgeStore at the time, and was actually a cause of sort of many of our load problems.
Sure, the bloat. I mean, right. This is all and when you say log data, what you're really talking about are all the events surrounding access to, and by Dropbox customers and their users, right? What objects they're touching, when are they touching, right? Exactly. The metadata that surrounds the service, right? It's not just the objects themselves; it's the actual and in many cases, the event data around these objects can actually exceed the storage size of the object, right? I mean, so depending on the nature and the velocity of change and the number of people who are making those changes, that event data and the size of the object itself, right? A small document that's touched by 1,000 people people, in a week.
It's a lot of events.
The metadata is going to be bigger than the object, right? So, and you can imagine in a corporate environment, right, most objects are going to be relatively small. These aren't like big giant blobs. So, the event data is significant when you look at it as a total size of the amount of data that Dropbox has to store as a service, right?
Yeah, absolutely. And it was sort of a very poor fit for EdgeStore.
Okay.
EdgeStore is, built on SSDs. It's very read optimized. We have entire consistent caching layer built in front of EdgeStore. None of which helps in the audit log use case because audit logs are just constantly writing and almost
and then they're never written or they're never read. They're always
Yeah.
written, right? It's like almost like a write-only database for the most part. But again, when you need it, right? So there has to be an access to retrieve it. There has to be a method to retrieve it. It doesn't necessarily have to be the most performant. Right? It doesn't have to be the lowest latency. Maybe it's not, because again, audit use cases, right? These are kind of like, oh, I need to find X because of Y. Well, until Y occurs, I don't need to find X, right? So, it's honestly, like you said, it's like, I just need a place to put it so that I can get it later, right? More or less. And so this is one of the things I talk to people a lot about. They start to consider the design, and you really good point when you talked about the one size fits all doesn't really work in this use case. And why? Because the access pattern of the data, right? So you need to understand what is your access pattern and how am I actually using this data? Am I a write heavy workload? Am I a read heavy workload? Should I optimize for the read? If I'm a write heavy workload, probably not. Well, it sounds like we're in a write heavy workload situation here. So let's talk about what Dropbox decided to do once they identified this issue.
Yeah, so at that point, we started looking at alternative storage places for this data. So we could, maybe move this data to Cassandra. We could run this in-house. We could deploy other sort of data storage systems. I mean, this was like 2 years ago at this point.
Right,
so
sure.
There's plenty of open source industry standard things that we could use.
Absolutely.
So we started evaluating different systems for storing this data. But I think sort of the biggest thing for us is that this data is still quite large volume in terms of how much data there is. So whatever system we chose really needed to optimize for the cost of storing this data. So one of the biggest sort of pain points of EdgeStore is how expensive it is because of this 3x replication factor and then another 2x for cross-region replication. So we sort of looked at can we archive this data on S3? Could we look at other things? We chatted with AWS folks a lot, I think, during this period of time, trying to see what sort of things could AWS help us with.
Sure.
I think in the end, we ended up not deploying our own systems, sort of for the same reason why we didn't do those other optimizations.
Right, a lot of work, right? A lot of expertise you got to grow in house. A lot of operational excellence that needs to be developed on your team. I mean, it's non-trivial to run a distributed database, right? Especially at scale. Absolutely. I mean, and that's what you guys were finding. You're already trying to do that with EdgeStore. You're running now. Granted, there might have been more elegant architectures, and possibly when EdgeStore was built 10 years ago or whatever, the best solution was sharded MySQL out there. I mean, honestly, DynamoDB's history. I don't know if we had the features and functionality that you guys required 10, 12 years ago, right? I mean, it was much more of a rudimentary service. So I don't know if the team would have made the same decision looking at that technology that long ago. But again, I talk a lot to teams about this, right? When you want to start thinking about the cost of operations, you have to put that into the TCO equation, right? You can't just say, I mean, like you guys said, if we split, EdgeStore that's another 1,500 boxes. What does that mean from an operational impact perspective? Oh, well, let me see. My whole team is on that task, right? 724, 365 for the next, whatever. Well, not 365, but for the next 60 days, right? Yeah. Yeah, you're pulling in resources from across the company to try and stand this stuff up. Right now, with DynamoDB, what do you need? You need 1 million, WCUs. Well, you might have to give me a call, but the reality is, okay, no problem. I'll turn that on for you. Right? We're just going to have a little conversation to make sure that's what you need. Right? I mean, a lot of times customers will ask for heavy amounts of capacity, and we talk to them and say, oh, well, wait, if you architect things a little differently here, but you guys leverage the AWS, service team and the SA team, up front in this exercise. Let's talk a little bit about that. I mean, how helpful were those guys? What were the resources you pulled in to these discussions, and was the AWS team able to help you guys out?
Yeah, I think you guys played quite a big role in this decision-making process.
Right.
Helping select the right services. I think we actually chatted with you as well.
Yeah, absolutely. I think I remember some of those calls. Absolutely.
I think it was definitely critical to this implementation.
Yeah.
And we had a good relationship with AWS, obviously, from S3 and storing block data already.
Yeah.
So this sort of naturally grew out of that. And during the process of building the system as well, AWS was very helpful with like features that we requested or bug fixes, anything like that.
Nice.
A lot of design sessions at the beginning.
That's great. I mean, and that's where we want to provide the value, right? Because that's, I mean, if you guys launch and you have a bad experience, then that's not good for anybody. That's not good for us. That's not good for you. And I can't emphasize enough to folks out there that are looking at launching new services on AWS. Everybody has an account team. Even startups have account teams. Reach out to those account teams and talk to those people. You may not be a big enough customer to warrant getting like an enterprise specialist FA engaged, but you can certainly get pointed to the resources that will help you, and there are specialists out there that are available to work with customers that have those mission critical workloads, right? So, I mean, it's something that is a very valuable service offered by that pre-sales team and the ongoing account team. Definitely leverage that. I mean, and it sounds like you guys got a lot of value out of that in this exercise as well. So that's cool. Absolutely. I remember those calls; those were really fun calls back in the day. I mean, you guys had big problems, right? So I like to talk about those big problems with customers because I really do believe Dynamo is a solution for so many different types of workloads. And so let's talk a little bit about that. What was I think you've got some content here you can kind of walk through. If you're in are your charts ready? I'll go ahead and add them to the stream. Let's talk a little bit about Alki and what the architecture looks like.
Yeah. So basically, for audit log event ingestion, we've got data that's sort of logged for a specific team, for specific users at certain timestamps, right? Mm-hmm. So it's sort of like it's almost like a time series data. And it's sort of coming in, and the way that we sort of built this around Alki, you can think about it as data comes into a certain time bucket. So, for example, it's coming into November 9th. And over time, as the day passes, no more events will get added to that bucket. So that bucket is sort of is now immutable.
Closed. Right. Closed. Yeah.
And then we can start ingesting data into the new bucket and so on. And so you've got all these old buckets that are immutable. So what could we do with them? We could maybe offload that onto a different storage service. So you could ingest data into sort of the current day using some system that can sort of ingest those writes. So something like DynamoDB as an example, and then offload the old buckets to S3. But you've got a problem where the data that you're looking for. So say we want to look for Team 17. And we want to list all their events
across a time range, like maybe across the last 6 months, right? Yeah. Right.
Now, if this was all in DynamoDB, it'd be very easy. We just issue a query to DynamoDB.
Sure.
But obviously, because this data we don't want to store it in DynamoDB, we want to offload it for cheaper storage.
Right.
We would need to then also go and scan the older data.
Right.
So if you squint a little bit, it sort of looks like a log structured merge tree, where we've got sort of a hot data, which is usually stored in RAM, and this is your mem table. But sure. Instead, we're using DynamoDB here for ingesting writes right away.
Sure.
And then over time, as you offload that mem table onto disk, instead we offload DynamoDB onto S3, and then we maintain a mapping of all the data that we store in S3, lookup tables, basically.
Okay.
And then you can, whenever you want to read a piece of data, you can sort of go look at your lookup tables for all the runs. Say, does this run contain data in this key range?
Okay, so you kind of think of those lookup tables are like indexes of the log files you have in S3. Say basically these log files contain events related to these objects of interest, right? So okay, so I query the run table. I say here's where my stuff is, and then I go to S3. I say okay, I know we have this object has some data I'm interested in. Let me go read and parse. So the data stored in S3 is really just kind of sorted, by whatever, the indexing attribute is, I suppose.
Yep.
Nice.
Yeah. So one of the problems that we faced here is sort of how do you store the index for those runs?
Sure.
Traditionally, I think in an LSM tree, you might store, like, as an SS table, you might store that lookup table in the run itself on disk. And so we could do this. We could store the indexes for these runs in S3, but then the latency would be quite high. In order to read a certain blob from S3, you would need to actually go fetch the index in S3 first, which is like a 60 milliseconds already gone, and then do another fetch for the actual blob itself.
Sure.
So that's not quite great. But then you sort of realize, oh well, we're already using DynamoDB for ingesting the hot data. Why not use DynamoDB for storing all the metadata as well? So that's sort of what we arrived at. Is we have these daily tables per index.
Okay.
In DynamoDB, which store the hot data, and we offload to S3 as well.
Okay.
But then we also keep a set of metadata tables inside DynamoDB itself that track what are the runs in S3, what are the sets of blobs.
Okay.
And then for each run, sort of what is the first key in each blob.
Okay.
So then you can sort of for any blob or for any key, you can find it in the set of blobs by looking for, like, what is the blob that has a first key that is just smaller or equal to your key.
Got it. Right. And so that way, okay, so then from if the first key is greater than the key I'm looking for, then nothing's in that blob that I'm interested in.
So you can do a reverse query with a limit of 1 to find the exact blob that might contain your data.
Okay, got it. And so, but you're not necessarily ruling out that there's nothing in there that I'm interested in. You're just saying that if there's something I'm interested in, it's in this blob, right? So that's kind of reducing the number of blobs that I need to look through to find my, the nuggets, so to speak, that I'm interested in. Right. Absolutely. Okay. That's nice. That's really what we want to do, right? In all these types of things, it's like, look, I don't care if I'm reading a little extra data. I care if I'm reading a lot of extra data, right? Yes. So if I can get rid of 90% of those blobs that I have to search through, then this is great. So that kind of sort key structure in DynamoDB, partition key, sort key structure works really, really well, because you can use those range queries and just say, give me everything that's less than or equal to me, right? Yeah. Oh, no, that's a nice, elegant solution to identifying which blob to go search through. Now, this is relevant to a question that popped up on the stream here. It's like somebody asked how many sessions with AWS were there, more or less, to come up with this optimal solution, right? We described this great solution. Now, obviously, it's not something that was proposed on day one. So, sure. How much interaction with the team, I guess, would you say? I mean, and it seems to me that in this solution, you probably had pretty much constant touch, right? I mean, this was not something that's going to be like, hey, you meet with us once, you run away, you don't talk to us again until you're ready to say, is this the right answer, right? You guys, let's describe a little bit about what that relationship looked like. I mean, did you guys have account SA? Did you have dedicated resources? Did you have professional services engaged? It seems like people want to kind of know, from how much investment was made by AWS and how much interaction there was in the course of this engagement.
Yeah, so I think in the early days, this was almost a constant interaction with all of the above. Obviously, like, some of the design work, sort of comes out of this, this collaboration. I would say that as we push this out to production, that interaction lessened. Obviously, things were running smoothly, so we didn't need to interact as much.
Right.
I don't remember off the top of my head how many interactions.
Yeah, it's hard to say how many, right? Dozens, maybe. Yeah. I know what it's like when you get into these engagements. It's like hard to quantify. It's like, although it's funny because sometimes, you meet with the team, and I've had this happen sometimes where it's like you meet with the team and that light bulb goes on and they go, wow. But your solution was multi-tiered, right? It's not just like, hey, I'm going to architect for DynamoDB a nice data model and we're going to be good to go. Like you said, that would have been the one size fits all approach, and the data cost, the storage cost in DynamoDB of leaving all this data. Granted, you're getting rid of the operational overhead. You're getting rid of the impact on the organization of having to scale in big chunks. But you're still cost your TCO. I mean, I'd run the numbers. I'm sure it might be lower than your edge store solution, probably because of the operational overhead, but it certainly wasn't optimal. What you came up with was a nice optimal architecture that said, look, and it really did take all those tenets and best practices to mind in when you start to design, right? What is the data lifecycle here? I think that kind of the key for the Dropbox team in this whole exercise was identifying that we're storing a lot of data in hot storage. Yep. It doesn't really belong there, right? And so how do we efficiently get it out of that and into a form factor that's still accessible and solves the mission of the service, but doesn't run the same cost, right? I mean, that's really what we came.
Yeah, so I think we sort of went in knowing that we wanted to do this sort of two-tier approach with a hot tier and a cold tier.
Right.
And you guys really helped us design what the hot tier
that looks like, right? Yeah.
And from there, the rest of the pieces sort of fell into place.
Yeah. So how do we do how does the migration work, right? You got these tables, they're daily tables. At some point you close off the table, you say, okay, let's get this to S3. Is there any kind of post-processing that occurs on that data? Let's describe that workflow. I mean, I see step functions workflow here. Yeah. What is that? What's the magic here that takes the data from your hot table and puts it into the cold storage? And what does that workflow look like?
Yeah. So we have a whole workflow for sort of managing because we have daily tables, so every day we're creating new tables. We have a workflow for managing this whole table lifecycle. So at the beginning of a day, actually several days beforehand, because we don't want the workflow being down for a couple hours to
sure.
So several days before the table is actually needed, we will create this table and we'll set it to on demand.
Okay.
And then that way, if this entirely fails to set provisioning when the day actually starts, at least it'll be accessible.
Right. One second, John. I hate to interrupt you, but again, one of the people on stream is requesting that we enlarge the presentation. If you click on that little thing that looks like a book, right there you go. Oh, did you click on that?
Yep.
Oh, that's weird. Usually that shows the full screen within your window, but it doesn't look like it did.
I might have to reshare.
There we go. That should be better. Awesome. That's the perspective I think people want. So yeah, sorry to interrupt you. I don't know where your thought train was there, but resume.
Yeah. So we have to manage these daily tables, and that includes provisioning. It includes creating the table, all that stuff. So at the beginning of a day, once that table is created and is needed, we'll set the provisioning that we actually expect from that sort of index that day. And then that helps us keep our costs down while we're actually ingesting data. Yep. And then at the end of the day, we'll remove the write capacity from the table, and we'll increase the read capacity, and we'll sort of begin this offload process. Mm-hmm. At the beginning, the offload thing that we used was literally just calling the scan API.
Okay. Yeah.
So we had our own sort of batch processing system, which would then go and call scan on a bunch of different shards, and then offload this data to S3.
Okay.
And this worked well for us because for audit logs, data is partitioned by team. And so throughout the course of a day, there will be sort of enough events for a team that when you do a scan, and scan only sort of guarantees that data within a partition gets returned in order, but not across partitions. Mm-hmm. So this scan, we could scan, and all the data that would come back, we could sort of immediately write off to an S3 blob.
Got it.
And it would be in order. And across partitions, the ordering would be maintained by this blob index.
Okay.
So at the end of the day, we do this offload process, take the data from the DynamoDB table, stick it into S3, do all the indexing that we need, and then we run sort of a series of verification and post-processing. So we might want to sort of partition the data in S3, just so that it's easy to operate on with other batch processing jobs that we want. And then we also sort of verify that all the data that was in DynamoDB, hash it, the hash of that data is the same as the hash of the data in S3.
Okay.
That way you can sort of confirm that the transformation that is
complete. Yeah, and true. Right, exactly. Yeah, yes. Yeah.
So then at the very end of that, we then go and we just delete the table.
Yeah, because you don't care once the raw data has been refactored and put back into S3, then the daily table goes away. You don't want to pay that storage. And again, this is the key thing to a couple key points I'd bring up here is the elastic provisioning, right? During the day, I don't need to worry about reads. I'm not provisioned for reads. I'm worried about writes. At the end of the day, I've got a bulk transfer I need to execute where I'm going to execute some scan or read operation. Now, quick question. I think when we built this solution, the team did not have access to one of the more recently introduced features, which was export to S3. Is that something that the team would have considered at the time? Or it sounds like there's some batching and bucketing of the data that you wanted to do. So not sure if that's but I mean, maybe would you thought or would you have thought about maybe export to S3 and a bucket trigger to do the processing or something like that rather than increase read capacity and scan and write or whatnot, or the step functions? Are there things, I guess the question is, knowing some of the new features that have come out recently since you built this service, are there things that you might have considered to do differently? And I wouldn't even suggest that you change this at this point because it's a system in place. We got to respect the system in place, and I think it's a great system. But would there be things that you would have leveraged the features that came out after the fact? Yeah,
so we actually recently, in the last 6 months, I guess, rewrote how the offload process works.
Okay.
So we did look briefly at the export feature.
Okay.
And it doesn't quite fit what we need because of all this indexing and things that we still need to do.
Yeah, you got to process the data anyways, right? So it makes more sense almost, and you might even repackage in a way that's not consistent with how the table stores it, right? Yeah.
Right. Yeah. So to handle this problem I talked before about, the scan API doesn't actually guarantee ordering across
partitions.
So if we have data that has a very little amount of data per partition, for example, if we had logs for per user as an example, then the number of partitions is very high. But throughout a day, there might only be a handful of events per user. So if we wanted to use the old offload workflow that we had, we would end up creating a blob per user with only 3 to 4 events per blob, which is
not very not nice and searchable, right?
We would pay both a very high cost for the blob index and a very high cost for all the S3 puts.
And that's a good point you bring up there too. A lot of people don't understand the cost in S3 is about puts and gets, right? I mean, there's storage cost, yes, but really the cost is if you're putting and getting a lot of small objects at high velocity, S3 is going to burn you really bad. So you want to get, and it's not, it's just not a burn. It's just you need to be aware of this, right? If you're running high velocity puts and gets, let's make sure they're doing them against big objects, right? Otherwise, let's bundle those items up into larger objects like what you guys are doing, so that puts and gets don't kill you, right? And that's and this is one of the things that when you work with the AWS teams, I'm sure they brought this up to you right away. Unless I know some customers have been burned by that in the past, which is just terrible. And hopefully hasn't been your experience, and that's why you knew. I
think it makes sense. The cost model sort of makes sense from a system architecture perspective. If you think about S3 as like a blob store, it's intended to store a lot of data, not intended to read and write very fast. So the cost sort of reflects that.
Yeah, that's exactly. I think that's a great way to put it, right? If you have high velocity data that needs to move around, it's maybe not the best place for it to be. And honestly, there's lots of strategies for that. Maybe what you really need is to identify where the data exists or whether the data exists. We can put that in, like as you did, build your index tables in DynamoDB, so you do quick lookups and filter out the objects that you need that are interesting to you, and then go get those objects, right? So you don't pay the big heavy storage cost for this data that sits there and is never read. But when you need to read it, you can find it fast and you can parse it efficiently and you can serve it up to the client. That is the nature of the Alki service, right? That's what you guys are responsible for doing is providing access and reliable access to that data in a cost efficient way, as opposed to what it was happening with EdgeStore, right? EdgeStore was getting crushed by the nature of the data. So what is the future of EdgeStore, right? I mean, we're going to see Alki take over more responsibility for this types of data storage at Dropbox. What's going on there?
Yeah, so we're continuing to use Alki for more cold metadata.
Okay.
So we besides Edge Store, we actually have yet another very large metadata database within Dropbox. It's specialized. It holds all of the file system data.
Okay. Okay.
This is the thing that sort of powers the file sync and share it. It stores all of the data about what your Dropbox folder actually looks like. So that, as you imagine, can also have a lot of cold data.
Right.
People who have put files into their Dropbox and then don't touch them for 6-7 years.
Right. Yeah. I'm one of them. If that's a bad customer, I'm sorry for being a bad customer.
The most of that data is actually quite cold.
Yeah.
And so we have ingested a lot of their data as well.
Sure.
And this rewrite of the offload process that I was talking about was sort of designed for this. So we actually shifted from using just the scan API to using EMR to do all the offloading and sorting of this data.
Sure.
And then basically for the file system data, instead of writing it directly to DynamoDB, because it's already in another database, we actually just sort it using this EMR process and then write it directly into S3 with the whole indexing into the DynamoDB metadata. For Edge Store itself, what's next there? There's a separate team that is looking at adding incremental capacity to Edge Store.
Okay.
So we do still have a lot of metadata stored on Edge Store.
Right.
Stuff that does fit for it. So things that are very read heavy.
Sure.
Things that you would expect from a OLTP database.
Okay.
There's a team there that is sort of working on swapping out MySQL under the hood with sort of a key value store instead.
Got it.
And then
are we talking to them? I want to talk to them.
Incremental capacity through that, which I think it's a very common thing to do. I think you'll see like Facebook does this a lot.
Sure.
They've swapped out a lot of their MySQL with RocksDB powered things. No doubt. I mean, there's a lot of different ways to solve these problems, and there's a lot of different solutions that make sense depending on the nature of the workload, right? I mean, one of the things where DynamoDB starts to break down for customers is potentially high velocity workloads that run, at constant rates, right? The cost comparison between running it yourself and running it with Dynamo starts to break down when you get to 90% constant utilization, 724, 365. But that's a very small percentage of workloads out there, right? I imagine even at Dropbox, you guys have peaks and regional, you may follow the sun. I'm sure your business follows the sun, but the services that you have deployed globally see their own daily, weekly, monthly, peaks and valleys in demand, right? As Alki does, right? You're not always, running at 90% utilization. Sometimes the service is relatively quiet compared to peak, right? What does that look like? Do you have any idea of what your kind of peak to valley is, and what that demand curve looks like for Alki, regionally around the globe? Yeah. So I think it's around like 20 to 30% extra traffic during peak.
Okay.
Versus the valleys. We are global, so they're it sort of smooths that out, during the night.
Somewhat, right? Yeah, exactly. But I imagine that you have regional services, primaries, right? For your customers in APAC aren't necessarily hitting US West 1, right? They're, so on and so forth. So, but and I know how it works with global operations, especially. Are you guys running global tables? Are you guys geared for that kind of? So yeah, so obviously utilization kind of, as you said, smooths out around the globe, especially when you add regional redundancy and whatnot. But 20 to 30% peak to valley is significant. Are you guys doing what do you run on? You run auto scaling with provision throughput, or how do you adjust capacity, so to speak, during the day? Are there any systems you have in place for that, or you just kind of go with the built-in stuff?
Yeah, so we do rely on the built-in auto scaling. Mm-hmm. We do have a separate system that monitors whether auto scaling is working.
Yeah, absolutely. Got to do it, right?
Sets provisioning if we have to ourselves.
Okay. And does that happen frequently, or is that something that you kind of is more of a check and balance?
Yeah, it mostly works. The main thing that we have to worry about in this daily table approach is that traffic at the beginning of the day spikes from 0 to the daily traffic.
Sure.
So
sure.
that's something that we have to pay extra attention to provisioning
Uh-huh.
and also partitioning. So in the reInvent talk, I talk a little bit about how we sort of pre-partition these tables,
Right.
to make sure that we, by the time that it starts to receive traffic, it is already scaled
It's
up.
already got enough partitions to handle it, right? This is key. I see this a lot where customers, but I can't use DynamoDB because it takes too long for the table to get to the point where I need. If I deploy a new table, it can be hours before it splits out to where I need to. I mean, if I've got an on-demand table and I deploy with default, settings, it's going to deploy with one partition. And if I need 10,000 WCUs, it's going to have to split 4 or 5 times to get there, right? So I talk a little bit about this in some of my other sessions, but very important point, right? When and I like your best practices there. You're pre-creating these tables, you're pre-partitioning these tables, and so that when you turn them live, they not only do they already exist and they've been validated, but they're already scaled. They're already scaled, and you don't have to worry about any of those types of hiccups, right? These are all really good best practices that your team's following.
And these are best practices that were suggested by you guys. So
absolutely. No, that's great. This is what we're here for. We want to make sure you guys are successful. Overall, what do you see in the future of Alki? What's do you see this service growing? Adopting new workloads across Dropbox? What's that roadmap look like?
Yeah, so for Alki itself, I think the biggest lever that we have for impact here is continuing to find other cold data use cases that we can migrate to.
Sure.
Maybe even identify some way to automatically find what is cold and move it to Alki.
Okay.
But I think the impact of Alki sort of extends beyond just the service.
Right.
This was sort of a proof of concept that we could build a whole system very rapidly on AWS. And so it's that sort of model is now being carried across the company. How can we utilize hybrid cloud to really improve our productivity, improve our velocity, and sort of reduce the amount of KTLO that we actually have to use to maintain our own systems.
And that's really the bottom line, right? You don't want to invest the intellectual capital in maintaining IT infrastructure, right? You don't want those skills. You don't want to pay for those skills. You want the skills that are invested in your product infrastructure, right? You want people writing code that's meaningful to the customers, not monitoring scripts and people lives and synthetic transactions to make sure that the routers are all configured correctly and things like that. That's just not something that an organization of the size and scale of Dropbox wants to invest in, right? It just doesn't make any sense.
So I think historically we invested a lot in that. We had this whole move where we built our own storage system and we migrated a lot of our data off of S3 onto our own data centers.
Right.
And I think for that use case, it sort of makes sense because it's at scale.
Right.
And that is something that is very unique to Dropbox. It's our competitive edge, so to speak. But for stuff like metadata, who really cares where we store that? We really only need it to meet availability, meet durability, and be cheap.
That's right. That's exactly right. You need a cost-efficient service to make it maintains accessibility and availability of the data. So there's a questions going up on the chat around we mentioned the S3 issue. And really what it comes down to is velocity and size of the objects that you're accessing, right? As your team identified in the course of your exercise, you don't want to create millions of small objects, one for each customer, each with just 3 or 4 events per day, because reading and writing those objects is going to become expensive, right? If that's the case, now it's not that there's plenty of customers I have that have that workload, right? I need to read and write millions of small objects, and I need to do it at high velocity. Then, hey, guess what the best solution for that is? It's DynamoDB, right? Because the storage cost of DynamoDB might be 20 cents a gigabyte versus 3 cents a gigabyte on S3, but you're not paying nearly as much for your puts and gets, right? A WCU in DynamoDB cost is a fraction of the cost of high velocity puts and gets in S3. So it's about the shape of the data, the velocity of the access pattern, as it always is, right? There's no inherent defect in any technology. There's only use cases for which these technologies excel and use cases for which they don't. And that is one of them. High velocity puts and gets on small objects is an anti-pattern. It's well documented in S3 best practices. And as your team identified quickly, certainly not something you want to do.
Yes. And I think one thing that I haven't mentioned yet, but for audit log data, reads of this data usually come in the form of like batched range reads, right?
Sure.
Like it's rare that the data will be read.
Right.
But if it is read, admins are probably looking at like how much all the data in a large swath of time.
Right.
So like a full sequential scan. So this actually works out really well for the way that we store in S3 because we batch these the data in blobs, right? So
right. You want ranges of
items,
items, so you can compile those into larger blobs. And as you said, you create an index that says this is the smallest key or the lowest key value you can expect in this. Give me all the ones that have a lowest key value that's at least as equal to or less than me, right?
Yes.
And then you know that I'm potentially in there, right? I mean, I like that. It's like, you're not trying to be definitive. You just want, I don't want to read 100% of the blobs and find the objects. I want to read 90. I want to filter out 90% of them, get those other 10%. Right. And if one or two of those blobs come up empty on my search, well, no big deal. I'm not paying the cost, right?
Yeah. And then once you do find it, each blob will yield 1,000 records. So then
exactly,
amortize out the latency cost of reading from S3.
That's right. And so you just need to reduce that initial read complexity or time complexity of your read, and you're going to be you're better off. So what surprised you, I guess I'd say in a good way, when you started with all this, and what were the things that really were like, wow, that was awesome. I didn't expect that, in either working with the AWS team or the feature on the service, or the way this all rolled out. What was it that you found to be pleasantly surprising?
A few things. I think one is like the interaction that we had with AWS. Definitely this like customer centric support that we received was very, very helpful.
Yeah.
I think beyond that, like it just works. Like, we don't have to worry about these scaling and reliability issues. It gives us time to focus on other work.
Sure.
Which is really nice. We were able to, build the system and scale it up with just a handful of engineers.
Okay.
In a very short time, right? So that was surprising. I think one thing that I thought would be really annoying, but actually turned out to be quite nice, designing around like cost and limits.
Right.
So it's different than working on-prem and designing systems for on-prem.
Right.
And I think it's a good thing because it's easier to reason about like a cost.
Right. What do I want to make the investment in? Right.
Exactly.
I know that's really. Oh, go ahead.
Yeah, and these limits, because they capture like all the things that you might need to think about when you're working on-prem, like hardware throughput, disk wear, capacity management. All these things get summarized into hard limits that we can exceed. And then, cost that we end up having to pay. So then it's really easy to sort of figure out, will this system work? Because it's too expensive.
Yeah, here's my cost break. Here's where I break on cost, right? Here, and what I'm really glad you brought that up, because I really hammer on this point, because a lot of teams kick back on that, but now I have to worry about WCUs and RCUs, and I'm like, well, you know what? You always did. You just didn't care, right? I mean, IOPS are the concern of the DBA, right? I mean, he's the one that has to figure out, why are your queries killing me, right? And now you're more responsible for your data. You're more responsible for the cost of your workflows, and you get a granular result, right? I mean, you can pull the return consume capacity off of your DynamoDB queries, and you can measure the actual cost of each individual query and throw it right into an Excel spreadsheet and say, hey, marketing, you say we're going to do X. Great, this is the cost. And you know what? When you do Y, you don't have to pay it, right? If you do 2X, right, then guess what? The capacity is there for you. Like you said, it just works. You just turn it on. If the system is wildly successful, you know what? It's not your responsibility to make sure the capacity is there for you. It's ours. And we take that seriously, right? I don't know. I have never seen a capacity request denied because we don't have the infrastructure, right? I've seen it denied because it doesn't make sense, right? I mean, it's not really denied. What'll happen is somebody will come in and say, I need 10 million WCUs. They'll say, oh my gosh, you need to go talk to Rick. And then I'll talk to him and I'll figure out what they're doing, or someone like me will talk to him and figure out what they're doing, and they'll go, no, you really only need 1 million WCUs and do it this way instead, right? So, but other than that, those are the types of things that happen. So calling out the fact that designing for limits, designing for cost, sooner or later you have to.
Exactly.
Right. I mean, that was the exercise you went through to replace Edge Store, right?
Yep.
It's going to be too costly to do this, right? So if you take that in, factor it in up front, then it's a lot less painful in the end, right? So, what were some of the things that you kind of said, ouch, I would rather it worked a different way than that?
Yeah. I think on the same sort of note, provisioning and auto-scaling still
needs work.
Still needs work.
Yeah.
It's still quite painful.
Right.
There's a lot of extra complexity that we have to build into Alki. Like pre-partitioning, stuff like that. And I think especially for use cases where we don't have the benefit of traffic at scale,
right?
For Alki, where a single client can actually affect the total amount of traffic towards Alki quite a bit. Whereas like on Edge Store, a single client is a blip in the
breeze, right? Yeah.
Exactly,
I mean, it seems to me, and I've heard this before, it would be nice if we could create a hybrid of on-demand and auto-scaling, right? Yeah, we could say, hey, here's my provision baseline, everything over this on-demand me, right? I mean, this is, and you know what? I can't say we will or we won't. I mean, I'm sure that, this has been something I've heard often. And when I look at DynamoDB's evolution on pricing and capacity planning and provisioning, it's really been amazing compared to 10 years ago where we were, where, here you have provision throughput and reserve capacity. And those are your only two options. Now we have, auto scaling with provision throughput. We have, what do you call it, on demand, and the ability to support workloads that just didn't even make sense before, right? I certainly see these things absolutely coming down the pipeline as more features, easier, more elastic, and lower cost, right? That's what we're always trying to do, is provide things through at lower cost. Now, if you had a magic wand and you were to say, hey, look, you guys, if I could just wave this magic wand, this is the feature I want tomorrow, right? Do you know what that feature might be?
It would either be that.
Okay.
Or some sort of like auto increment field that could be used in the key.
Okay, auto incrementing keys, auto incrementing integer values, things like that.
Things that can be used to sequence writes to DynamoDB.
Sure.
There's also a lot of complexity in Alki that comes around this logic that we use to sequence the writes.
To sequence things. I've heard this issue. This is a problem across all distributed NoSQL databases, right? The ones that have solved unique ID problems, they do it with UUIDs. This is definitely a discussion that goes back and forth, right, across the org. And it's not an easy, surprisingly, it's actually not an easy problem to solve, right? Because this thing operates in a distributed, horizontally scaled, solution. So all NoSQL databases have stuff.
That's why it's a magic wand.
Magic wand ask, right? But you know what? I mean, it's something that I know the team is out there and they're working on. What is it, right? So how do we make this work, right? So potentially there's things you can look at. And what's interesting is some of the technologies these days around like chip level atomic clocks and things like this, where you can actually guarantee clock synchronization across instances, even just globally distributed, right? This starts to open up potential for doing things like this, right? So we could start thinking about along those lines. Anyways, John, we're getting to the top of the hour here. I'm going to take a quick look here and see. So I'm not seeing. I guess there's a question there. So the question, and this comes down to the kind of nature of the workload you talked about, right? There's a why store the data in DynamoDB in the first place? And it's kind of the, well, look, we've got this high velocity event stream, right? The events are relatively small objects. We don't want to push all those directly into S3 because they need to be aggregated someplace. And so this is what we're doing. We're using the DynamoDB table as kind of that hot event store. And then, on a daily basis, we bundle all that stuff up and push it out to S3 as larger objects, so we don't have to pay that cost of those high velocity small updates into S3. And searchability, right? I mean, if there's no aggregation stage on that event data, then on the back end trying to find it is miserable. You've got potentially billions of objects you're going to be sifting through, and you're probably looking at map reduce on top of this, and again paying the cost of a high velocity read stream on all those little tiny objects, right? So that's really the reason why you're doing this, right?
Yes, I think the key here is the searchability. So if we were to immediately write, we could still batch objects that come in immediately and write them to S3, right? But they would be unordered.
Right. Exactly.
If you wanted to search that, you could either search all the data, or you could keep an index to every single row in S3. But if you have an index for every single row in S3, then that index itself is roughly
the storage
size. It's metadata. The objects in S3 are small, so then the the ratio of the metadata that you keep to point to the object in S3
It's
is
going to
like
be high, right? You might as well
Exactly.
just keep the objects in the searchable index, right? Exactly.
So the point of DynamoDB there is to provide us a place to pre-sort all this data throughout the day, batch it all up, and then export like a fully sorted
Yes.
batch of rows to
indexable objects that are more efficiently structured, right? I mean, this is the key.
We can keep a very sparse index in DynamoDB where we only store metadata about like the first row in each one.
Right, the first row in each one, right? And anything, yeah, that's the event ID we talked about. Okay, John, we're at the top of the hour. Thank you so much for your time. I really appreciate this. I'm sure folks enjoyed talking about Dropbox. I really look forward to working with you and the team in future projects. And I'm so glad this worked out for you. And thank you so much for joining us.
Thanks for inviting me, Rick.
All right. I'll talk to you guys later. Bye.
Bye.